This is Chemistry for Grade 10. Produced by Tigray Education Bureau. Transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media. And also FM Maqala 104.4.
Hello students, welcome to Chemistry lesson in grade 10, program 3, presented by Brhan Hagush. Students, in the previous lesson, you have learned property of salts. Some of them, aqueous solution, soluble salts are good conductor of electricity, thermal stability of salts. All salts are not thermally stable. And also, you have learned plant nutrients, fertilizers, pesticides, and herbicides. Today, you will be learn the new chapter, Unit 3, Electrochemistry. Students, at the end of this section, you will be able to define electrochemistry, electrical conductivity, electrolysis, electrodes, and also explain the difference between metallic and electrolytic conductivity. Students, let us proceed to our today's lesson. Can you define the term electrochemistry? Let me repeat the question. Can you define the term electrochemistry? Answer. Electrochemistry is a branch of chemistry that deals the relationship between electrical energy and chemical energy. Do you answer like this? Very good. Electrochemical cell. Electrochemical cell is a device that converts chemical energy to electrical energy or electrical energy to chemical energy. Let us proceed to electrical conductivity. Electrical conductivity is the capacity of a substance to transmit electricity. The materials that allow the passage of electricity through them are called electrical conductors. Conductivity apparatus. Conductivity apparatus is used to test the conductivity of different solid substances or that of aqueous solution of different compounds. The basic components of conductivity apparatus includes electric wire, electrodes, dry cell, switch, and light bulb. Students, see in your textbook on page 163 how the components of the apparatus can be connected to one another. Depending on the nature of the particles responsible for the flow of electric charges through conductors, electrical conductivity can be classified as metallic conductivity or electrical conductivity. Let us see each other. Metallic conductivity. Metallic conductivity is also known as electronic conductivity. Metallic conductivity refers to the transmission of electric current through metals. Metals transmit electric current due to the presence of free electrons or mobile electrons. Non-metals are generally non-conductor of electricity because they have no mobile electrons. The only non-metallic conductor that transmits electricity in solid state is known as graphite. Students, let us see electrolytic conductivity. Electrolytic conductivity. Electrolytic conductivity is also called ionic conductivity. Electrolytic conductivity is the movement of opposite ions in opposite direction through the electrolyte. The charge carriers in electrolytic conductions are ions. Based on their degree of ionization, they produce cations and anions. Electrolytes are classified as strong electrolyte or weak electrolyte. Students, can you explain the difference between a strong and weak electrolyte? Have you tried it? Excellent. Let us see the difference between them. Strong electrolytes are electrolytes ionized almost completely in aqueous solution. Examples: strong acid, strong base, and soluble salts. Weak electrolytes are electrolytes ionized only slightly. Example: weak acid, weak base, and partially soluble salts. The substances that do not transmit electricity either in solution or in molten state are called non-electrolytes. Examples of non-electrolytes: ionic compounds in solid state, sugar, ethanol, oil, benzene, liquid nitrogen, etc. Students, before proceeding to the next section, here are some questions. Instruction: choose the correct answer from the given alternative. Question number 1. From the following substance, which one is an electrical conductor in its solid state? A. Sodium chloride, B. Sulfuric acid, C. Graphite, D. Potassium hydroxide. From the following substance, which one is an electrical conductor in its solid state? A. Sodium chloride, B. Sulfuric acid, C. Graphite, D. Potassium hydroxide. Answer: C. Graphite. 2. The major charge carriers in electrolytic conduction are A. Mobile electrons, B. Neutral atom, C. Cations and anions, D. Molecules. The major charge carriers in electrolytic conduction are A. Mobile electrons, B. Neutral atom, C. Cations and anions, D. Molecules. The answer is C. Cations and anions. 3. From the following, which one is a strong electrolyte? A. Sulfuric acid, B. Phosphoric acid, C. Carbonic acid, D. Hydrosulfuric acid. From the following, which one is a strong electrolyte? A. sulfuric acid, B. phosphoric acid, C. carbonic acid, D. hydrosulfuric acid. The correct answer is A. sulfuric acid. 4. All are weak electrolytes except A. carbonic acid, B. calcium hydroxide, C. sodium hydroxide, D. magnesium hydroxide. All are weak electrolytes except A. carbonic acid, B. calcium hydroxide, C. sodium hydroxide, D. magnesium hydroxide. The correct answer is C. sodium hydroxide. 5. The basic components of conductivity apparatus are A. electric wire, B. electrodes, C. light bulb, D. all. The basic components of conductivity apparatus are A. electric wire, B. electrodes, C. light bulb, D. all. The correct answer is D. all. 6. Which of the following conduct electricity? A. molten sodium chloride, B. solid sodium chloride, C. sugar solution, D. alcohol solution. Which of the following conduct electricity? A. molten sodium chloride, B. solid sodium chloride, C. sugar solution, D. alcohol solution. The correct answer is A. molten sodium chloride. 7. Compounds that do not transmit electricity in solution or molten state are called A. weak electrolyte, B. strong electrolyte, C. non-electrolyte, D. electronic. Compounds that do not transmit electricity in solution or molten state are called A. weak electrolyte, B. strong electrolyte, C. non-electrolyte, D. electronic. Answer C. non-electrolyte. Students, have you got the answers? Excellent. Let us proceed to electrolysis. Electrolysis is a process in which electrical energy is used to produce chemical change, or it is also defined as the decomposition of an electrolyte using electricity. Electrolytic cell uses electrical energy to bring chemical changes. A typical electrolysis cell contains a source of direct current, an electrolyte, connecting wires, and electrodes. Students, let us define the term electrodes. Electrodes are a strip of metal or graphite that allow electrons to leave or enter the electrolyte. Electrodes can be chemically active or inert. Active electrodes are electrodes directly take part in chemical reaction. Example, zinc and magnesium. Inert electrodes are electrodes do not directly take part in chemical reaction. They only serve to transfer electrons. Example, platinum and graphite. Electrodes based on ions they contain can be classified as anode electrode and cathode electrode. Anode electrode is a positive charge rods connected to the positive terminal of the source. Anode electrode is the electrode at which electrons leave the cell. Cathode electrode are electrodes and negatively charged rods connected to the negative terminal of the source. Such types of electrodes are in which electrons enter the cell. During electrolysis, the ions of the electrolyte migrate to the electrode of opposite charges. Cations are positive ions attracted to the negative electrode called cathode. Cations are discharged by gaining electrons. The process of gaining electron is called reduction. Anions are negative ions attracted to the positive electrode called anode. Anions are discharged by losing of electrons. Oxidation reaction takes place at anion. Half-cell reaction is the reaction that takes place at each electrode. There are two half-cell reactions. Oxidation half-cell reaction occurs at anode and reduction half-cell reaction occurs at cathode. Cell reaction is the net or overall reaction that takes place in each electrolytic cell. In the electrolysis process, the electrolytes are either in the form of molten state or aqueous solution. Students, see in your textbook on page 169 the process of molten electrolyte, cathode reaction, anode reaction, and cell reaction. Students, today you have learned the definition of electrochemistry, electrochemical cell, conductivity apparatus, and basic components of conductivity apparatus like electric wire, electrodes, dry cells, switch and light bulb, and also metallic conduction, electrolytic conduction, and cell reaction. Students, please take a short note about these some points. Next time, you will learn about galvanic or voltaic cell. Until next time, goodbye.